All right, so welcome to the first session of Big Data with the Spark course. In this session, we are going to talk about first, we will go over the big data introduction. And then in the second half, we are going over the architecture of Spark. And if needed, we will also talk about the architecture of Hadoop. And afterwards, we will do the hands-on on we will do the hands-on on the CloudxLab. The objective of the hands-on is to make you acquainted with the services of CloudxLab so that in case you have taken the lab or you're planning to take a lab, it becomes easier for you to use various services and discover various features. All right. So is my voice coming through fine? Is there a noise or anything? All right. Great. Great. So all right, so the agenda for the session is that we start with introduction to big data, and then we will have a 10 minutes break near about the middle of the session, which is going to be 1.5 hours from now, and then we will have Spark and maybe the Hadoop architecture, and then we will have hands-on overview of the lab. So please introduce yourself using the chat window while others are joining. The session is being recorded and the recordings along with the presentations will be shared with you, with all of you. Okay. This is one first of the session out of 12 sessions on big data with Spark specialization. It generally suffices as the introduction to big data technology stack, specifically with Spark. Now, so everyone except me, who is the instructor, is muted. Please ask the questions by typing in Q&A window. I will read out the questions before answering. To get the better answers, keep messages short and avoid chat language. All right. So great, great. So let's get started. So the a brief about CloudxLab. CloudxLab is making learning fun and for life. And how are we doing that? By the way of live tutorials, as in live classes, instructor-led classes, and videos, along with quizzes, hands-on, and projects, along with the case studies, and all of these based on the real-life use cases. All right. The 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 hands-on that we talk about, they are basically automated hands-on assessment. The objective is to learn by doing. Okay, so the automated hands-on assessment has two parts essentially. One part is problem statement, and other part is the lab. So you perform in the lab uh, based on the problem statement, and then it automatically checks whether you have performed it or not. All right. Next is that, right? So these are the examples of hands-on assessment. You can see that here the problem statement is to log into the lab, and then once you are done, you have to click on I'm done, and this is an example of the automated hands-on assessment. That's a very simple example. The second example of hands-on assessment is this one, where on the left-hand side, the problem statement is to write a Python code in which we have to we have to define a variable x equals to 10. So we have to go to the right side and define x equals to 10. And once we are done with defining x equal to 10, then we can click on I'm done, please check, and it will basically evaluate whether you have done it correctly or not. In case we have done it correctly, so it's giving us the message that we have done a good job. All right, a brief about the instructor. A brief about the instructor. I'm Sandeep Giri. I graduated from IIT Roorkee in 2002, 15 years ago, and I worked largely on large scale computing, or you can say high performance computing. I worked with Amazon, InMobi, and DE Shaw. At Amazon, InMobi, and DE Shaw, I largely worked on the high performance computing or distributed computing. And then at heart, I'm software engineer and I love explaining technologies. So feel free to ask questions, feel free to um, write to us. So we would love to answer your questions. That's one of the reasons why we started CloudxLab. All right. So great. Great to have all of you in the session. We have very good attendance today. So the objective of the course is learn to process data with Spark. The objective of the course is learn to process data with Spark. And we might use a bit of Hadoop. So if needed, we will take you through those the technology stack. So that will be good enough for you. Okay, so all right. So before we get started, let's try to understand the basics of data or big data. So the first thing that commonly occurs is the definition of data variety. So let's talk talk a bit about what does it mean by data variety. Data variety is essentially data can exist in many forms. Data could be structured, data could be unstructured, data could be semi-structured. So what does it mean by unstructured or semi-structured? So the data which has columns as well as the data in which we know the data type of each column, that data we call structured. The structured data essentially has columns as well as the data type of the columns is the same and well defined. So the now that's called structured. What are the examples of structured data? The data that exists in any database in the form of tables is structured data. All right, like for example, data in MySQL, data in Oracle, data in Microsoft SQL, the data in the form of tables where every column has a clear data type and we know that data type, then we call that structured data. Now, on the other extreme is unstructured data. What is unstructured data? We neither know the fields nor we know the data type of the fields. Like for example, data in plain text file. Data in plain text file does not have columns and we don't know what would be the data type of columns. That kind of data is called unstructured data. That's completely unstructured data. In the midway between structured and unstructured, we have semi-structured data. Semi-structured data has fields, but we don't know their data type. Semi-structured data has various fields, but fields as in it has columns, like in case of comma separated values, CSV files, we know what are the columns, but we don't know upfront the data type of each column or each fields. So we generally, when we want to process the data, we generally try to convert unstructured data to structured data or semi-structured data to structured data, or maybe unstructured data into semi-structured data. So these processes are called ETL. ETL is extract, transform, and load. This process of extracting data from unstructured form into certain tabular form is called ETL, extract, transform, and load. All right. So the examples of structured data are data in databases. The examples of unstructured are data in plain text file or or maybe the images and so on. While the data in semi-structured form are the example of semi-structured form are like data in XML, data in JSON, data in the form of comma separated values, that is CSV. Right. Does the field refer to each record? Yes, that's right, Pinta. Good. So now the next definition that we will talk about is the distributed computing. What does it mean by distributed computing? Distributed computing is the groups of networked computers that interact with each other to achieve a common goal. So we have networked computers that interact with each other to achieve a common goal. So that is what is called as distributed system. So a system is not only connected in the network, but is also achieving a common goal. So a cyber cafe is not necessarily a distributed system. All right. So those were the basic definitions. Let's move on now. A question to all of you. Question to all of you. How many bytes are there in 1 petabyte data? Anybody? All right. Those are so many zeros. I can't even count, Hitendra. All right. Okay. Yes. It is 1024 terabyte, or you can also say 10 to the power 15. Yes. Very good set of answers. Now, second question to all of you is, how much data do you think Facebook stores every day? Any guess? No ideas? Okay. So how much data does Facebook store in a single day? It's approximately 600 terabyte as per them. Okay. It's about 600 terabyte. I don't know about current status, but that was the number given earlier by Facebook. All right. So now back to the definition of big data. So let's try to understand what is big data. Let me know your definition, your understanding of what is big data. Yes? Yes. All right. Before we start the session, we need to, because the whole session is about big data. The whole session and the entire session is about big data, how to process big data, various kinds of data by using various tools. So we need to be very clear about the definition of big data. So in very simple words, big data is data of very big size. And how big? The amount of data that you cannot process using the usual tools. That you cannot process using the usual tools. So what does it mean by usual tools? The tools that are not distributed. So we need we need to use the tools with distributed architecture in order to process such kind of data. So let me put it this way, that let's say you are trying to handle the data and you realize that you really cannot use the existing tools. You really cannot use the existing tools because they are not distributed in nature, as in you require the kind of computing you are dealing with requires many computers concurrently in order to give you the results. Okay, then we call that as big data. Okay, the amount of data which requires big data, which requires a distributed architecture, or in very simple words, the amount of data that requires many computers to solve the problem related to the big data is called big data. Okay, let me turn off the fan. Thank you, David. Okay, is it better now? All right, that's what I was asking earlier. Okay, all right, so great. So basically, a question Karthik is saying that any quantitative definition of very big size. There's no quantitative definition of very big size. You will see that soon. That sometimes it's the kind of problem that you are trying to solve that makes it impossible to use only one computer. So it has to do with the it has to do with many it has to do with the kind of problem that you are trying to solve and the amount of data that you are trying to solve handle. It is the function of both of the properties. All right, we'll come back to that as in the next session, next slide. Okay, this data that we just talked about could be of any form. The data could be structured, data could be unstructured. So data in any kind of form that requires you to use many computers, we generally refer that as big data in very simple words. Now, what are the characteristics of data? What are those characteristics of data that makes it impossible, or that basically require various computing resources, right? So the first characteristic of data is volume. Volume, what does it mean by volume? Volume is essentially the data at rest, meaning the data when we turn off the computer, the data that stays there in the disk. So sometimes there's problems related to related to storage of data. Those storage of data, when it becomes impossible to use a single computer to store your data, then we call that the big data because of the volume. Second, the velocity, the data in motion, the problems that involve the handling of data coming at fast rate. That's called velocity, the data in motion. So the number of requests being received by Facebook, YouTube streaming, Google Analytics, and so on. That's an example of velocity. Okay, so when we are transferring the data, or imagine the being received by number of requests being received by Facebook servers per second. That's data in motion. Or we, like right now, as we are all attending this session, as I'm speaking it, so it's being transmitted to hundreds of people. That's data in motion. And when because of the transfer, because of the data in motion, if you require multiple computers, that is called the big data because of the velocity. Now, let me take a step back, or give you another example. Imagine the number of requests being served by Facebook per second, right? There are millions of requests per second coming from millions of devices across the globe. Do you think that can be handled with one computer? Of course not. You cannot handle that with a single computer, and uh, therefore you generally require a distributed computing system. All right. The third characteristic of data, the third characteristic of data that makes it big data is variety. Sometimes not only the variety of data, but variety of the problem that you're trying to solve. Okay. Say for example, Google Maps. In Google Maps, we need to reach from one point to another. The Google Maps with respect to storage, it's not big. It can be handled. The storage of map could be handled with a single computer, let's say for a country. But since when we say go from A to B, there are so many steps, so many possibilities. Therefore, such kind of problems cannot be solved using one computer, or there are many other problems like, for example, genome, where the data is where the problem related to genome is so complex that we have to try many combinations. There also the computing resources become insufficient for the kind of problem that we are solving, and therefore we might require multiple computers in order to handle variety. Okay, so the thumb rule is when you cannot handle your processing using one computer, we generally call it a big data. All right. There is no hard limit. There is no exact limit, but that's generally the definition. Big data computing is analogous to distributed computing. Now, let me ask you a very simple question. Question is, how much time does it take to read 1 TB data from hard disk? Anybody? That's right, around 6 hours. Now, now a question from a very good question is, it depends on SSD or SDD. Correct. So here we are talking about SDD. Okay. So we are asking about how much time does it take to read the data from SDD. And we are talking about average. We are not talking about the extreme. Okay. All right. So next is my next question to all of you is, imagine that you have to count just the vowels in 1 petabyte data every day. Do you require a distributed system, or one computer is sufficient to do it? You are just counting the vowels. You are just counting the vowels in 1 petabyte of text every day. You have to do this every day. Can you achieve it with one computer? Or do you require distributed system? That's right. You would require a distributed system to store as well as to handle 1 petabyte data. The reason is this: if for storing 1 petabyte data, you cannot store one petabyte of data in one disk or one computer. Even if you did somehow, then just reading that data, 1 petabyte data, will take close to 6,000 hours. And therefore, it's impossible to store or handle 1 petabyte of data using one computer, because there are multiple bottlenecks. One is the storage, other is the read speed of the storage. All right. Great. Great set of answers. I just went through the answers. Good. So yes, most of the existing systems cannot handle it. So we would require the distributed system. We would require the distributed architecture. That's right. So now, why are we talking about big data in the first place? What is so new or what's so special about big data? The data, as you can see in the diagram, has been exploding, as in more and more data is being accumulated in the form of digital, meaning in the form of in hard disk, in cassettes, in hard disk, in solid state drives, in tape drives. More and more data is being stored in the digital medium, in the form of digital storage, while the data in analog storage is being is being shrinking, meaning the analog as in the form of books, in the form of paper textbooks, in the form of plain text. So in the form of physical books, that has been shrinking. So this has started happening. This has been happening after the digital era has started, close to 2000, year 2000, where the more and more connectivity happened. Now, this is something that has started in 2000, and why did that happen? The answer is threefold. On one hand, the devices became faster, smaller, and cheaper. On one hand, the devices became faster, cheaper, and smaller. And on the other hand, the connectivities. Okay, when I talk about devices, it means the devices such as smartphones, such as sensors, such as the wearables, the such as the diagnostic devices. So most of the devices, electronic devices, are getting smaller, faster, and cheaper. While on the other hand, the connectivity between devices has been going up. The connectivity is also becoming omnipresent, as in there is connectivity between the devices in all forms, such as Wi-Fi, 4G, NFC, and GPS. So you have all kinds of connectivity. On the other hand, and on the one hand, you have so many devices available. So when you think about this, the output of the two is, on one hand, devices generate data, and connectivity transmits them and hence multiplies the data, and therefore there is a huge array of applications that have come up to utilize or to help us put the devices to use. Okay, those applications could be social networking, internet of things, and so on. There are so many applications as of today. A question is from Bindao: what is NFC? NFC is a near field communication. It is for communicating between devices which are located very close to each other. All right. Most of the devices, except for iPhones, most of the Android devices have NFC enabled so that you can tap them and transmit the data from one to another. Now, next is next is to process and store data. We need CPU, RAM, network card, and disk devices. So let me take a step back and explain myself again. So as of today, the devices are getting. All right, let me take a step back. Okay, so on one hand, the devices have been getting better and better. On the other hand, the connectivity is improving, which is leading to so many applications, and hence the data is accumulating and data is growing. Now, what exactly is the problem with respect to handling the data? That can be understood by the way of looking at the computer. When you look at the computer, what do you see? The computer, even though it has many connections, it has many uh, many components, but on a very macro level, from the perspective of processing, you can think of computer as made up of four parts: CPU, RAM, network, and disk devices. CPU means the speed of the processor. In case of CPU, the parameter is the speed. What is a CPU? CPU is basically CPU is the main unit on the computer which can read instruction from the disk and take an action as written in the instruction. Take an action meaning it can execute an instruction. So it can convert a written statement into an action. That is the CPU. And so on the other part we have is RAM. So CPU reads the data from the RAM, the instruction that we just talked about. It reads those instructions, those commands, those orders from RAM and executes them. Okay, the more number of instructions CPU can execute, the better it is. So in case of RAM, both how many instructions can we store, as well as how big the RAM, how big the how, as well as how fast we can read from the RAM, both matter. So in case of RAM, the two parameters, the size and the speed, are the main concerns. The third one is hard disk or solid state drive. The hard disk, in case of hard disk, the size of the disk as well as the speed matters a lot. So hard disk or solid state drive, both are permanent storages. The RAM that we just talked about, in case you turn off your computer, everything you stored in the RAM is disappears. Okay, so RAM is basically RAM gets empties. uh, RAM gets emptied as soon as you turn off the computer, and RAM is also limited, so it's random access memory. It's kind of dynamic, as in the CPU keeps on reading from it, writing to it. So RAM is extremely fast, but is small, and it gets resetted every time you turn off the computer. Therefore, to store bigger data, to store bigger data, as well as to store the data permanently, we either need hard disk or solid state drive. Hard disk is bigger and cheaper. Solid state drive is faster and generally costlier, as well as it is smaller. So that is about the solid state drive and the permanent storage. So in hard disk or solid state drive, the data will remain there unless explicitly deleted. The fourth component that is largely ignored is network. And why does it matter today? In most of the cases, when we are reading the data from a remote drive or reading the data from a remote server, in all of those cases, the network is the one that plays a very important role. Or in other words, we can't fit the data when we can't fit the data into the local hard disk. We put the data into network. All right. So if the data is not fitting into the RAM, we put it in the disk. If the data is not putting in the local disk, we put it in the network. And these are the kind of optimizations we keep on doing as software engineers. Therefore, the network plays a very important role. A question from Mintao is, what is a bus here? Bus is the one that transmits the data between the CPU and RAM and so on. So that is the bus. Those are basically a bunch of wires, and using those wires, we read the data using the CPU from the RAM or from the disk. Okay, so that's how you can think of bus. Now, when it comes to big data, let's say that when we are doing the processing and we are keeping all the data in the RAM, if the data starts growing, what we do is we keep on putting into a hard disk. And after a while, it becomes impossible to store on the local hard disk. Therefore, we start pushing the data to network, and suddenly everything would become slow. And suddenly we would require a faster speed, and we can't achieve that using a single computer. And then we will realize that we would need a distributed computing platform. Okay, so at least one of these will become the bottleneck when it comes to big data. Either the CPU, RAM, or storage, or the network. Either of the four components will become the bottleneck when it comes to handling big data. Now, a question to all of you. Question is, which components impact the speed of computing? Anybody? Which components out of these impact the speed of computing? Which components out of CPU, memory, disk, and network impact the speed of computing? That's right. That's right. all of the above, it's a very important thing to understand that it's not only the CPU, it's not only Intel, or it's not only dual core or quad core that matters. It also, the other components also matter when it comes to computing. Now, next question is, we understood that fine because of various innovations, because of all kinds of innovations in the computing field. There is so much data being generated, and the computing resources are being i- insufficient. So what is the point? What kind of advantage do we get out of big data? What kind of advantage do we get out of doing the big data processing? The one such example is, there are many applications. First of all, there are many applications of big data computing. There are many applications of big data computing. Just let's talk about few of the applications or example of the big data computing. Think about the recommendations provided by companies like Amazon. Think about the innovations provided by, okay, so let me take a step back, and there are some questions that I need to answer. All right. Feel free to ask questions in midway. All right, let's take a step back and explain again. So far we talked about the data is increasing because there is innovation hardware, and there are various softwares because of which a lot of data is being accumulated and being generated and being transmitted. And the computer has the various components that make it impossible, that basically one of the components become the bottleneck, and that makes it impossible to do the computing using one computer. And therefore we need new set of computing paradigm. Now, why do we need, what's so great about handling humongous data? Can't we just do that using small data? Can't we just sample the data, keep only some amount of data, and and use that to do various kind of things? Can't we do that? The answer is no. Imagine a system like recommendations. What is a recommendation? Recommendation is recommending somebody something based on their choices, based on their past behavior. Like, I know your movie choices, the kind of movies do you like, and I recommend you that you may also like this kind of movies. That is recommendations. The other words that we use for recommendations is collaborative filtering, or simply recommender engine. So one such example of recommender is the Amazon. At Amazon, you can see that there are various kinds of recommendations. Some of the recommendations are of the form of, the people who bought this also bought that. The other kind of recommendations are, wear this with. The third kind of recommendations are, in case of Netflix, where it is showing that congratulations, based on your past history of movie preferences, these are the movies that we found that you will like. So that's another extreme of the movie recommendations. All right. So these are the examples of movie recommendations. So movie recommendations, can it be done on smaller data? Answer is yes. Will the will the recommendation qualities be better at smaller data? Answer is no. The bigger the data, the better are the recommendations. Bigger the data, better are the recommendations. Therefore, we need a therefore we need a platform or the framework to handle humongous data in order to give you meaningful recommendations. A question from Bharti is, in YouTube, we'll get recommendation videos. Yes, that's right. That's based on the past history of users. Okay, and most of the recommendation systems, the way they work is they find the similar users and they cross suggest each other's movies or each other's videos to the other person. Okay, another example of recommendation is Facebook friend suggestion. Thank you, Riyajur. All right, so those are a very good suggestion. So now, example of how will, let's say, recommendation work. Recommendation systems work by first preparing the user definition, movie definition, and the ratings, and then using a system like Spark MLlib to give the result in the form of user ID, movie ID, and the ratings. And how does these kind of systems work? They'll find which users are similar to each other, and then using a library such as Spark, they can give the recommendation to based on the past history of users, based on similarity of users. So Spark MLlib, for example, can process billions of records happily and give you the results really well. Okay, so that uses many computers simultaneously in order to give you good results. All right. Great. So I hope the example of recommender is clear to everybody. No? It's only clear to Robin. All right, great. Great. Let's move on to the second use case of big data. The second use case, the example of second use case is, say, A/B testing. What is A/B testing? A/B testing in e-commerce world is a very important process. Imagine you have a website and you are confused about whether to use green color or red color. Okay, so instead of keeping on arguing about red and green, the general strategy is that for 50% of the users or for some users, we will show red, and for some users, we will show green. And based on the conversions, we will decide which color is better, whether green or whether red. So from the picture, do you think variation A is better than variation B? Which variation, A or B, in the screen is better? There are two variations of the website. Both are getting the equal number of users. Both are getting the equal number of users in the traffic. And, or you can say, both are getting equal number of visitors. And the variation A is giving 23% of conversion, while variation B is Variation B is giving only 11%. So variation A or variation B, which one do you think is a better variation? Okay, A or B? I'm not sure about the colors. Yes, Raju. All right. Why do you think it's B? A is giving us 23% conversion. Conversion means converting a user into the customer. That's right. That's right. So basically, conversion means here the A color is giving us 23% conversion, meaning converting a lead into basically making sales. Here, out of 50% users, out of the, let's say 50 users came here, 50 users came here. So out of 50 users, 23% bought, while out of 50 users, only 11% bought here. So So you can see that the conversion here is better. So here we are making more money as we are making more sales and more users are really liking it. Therefore, we will stick to the variation A. All right, Raju. So that's what it means. Great. All right. So moving on. Now this is A/B testing. In A/B testing, if we have more and more users, we will get better results. And like for example, in case of Amazon, we had so many tests running parallelly. And the green color, the green color that you see for buy now button comes from a very thorough A/B testing. It has been noticed that that button, that kind of color brings more sales. That is one of the reasons why they have standardized buy now button on Amazon's website. All right. So that was A/B testing. Now let's talk about the the other big data customers. Let's talk about the other big data customers other than e-commerce. One other is government. The government uses big data for many use cases, such as fraud detection, cybersecurity welfare, and justice. So big data can be used in order to determine the, the causes of fraud or predicting a fraud based on the past history. Similarly, the cybersecurity welfare or warfare can be can be predicted, and we can detect the pattern based on the data if we have enough data. The third one is justice. In justice also, we use big data to get the insights or the sentiments of various text, and there we can use big data. Now, third one is telecommunication. The telecommunication is another big domain where every data, everything is big. So in telecom, we have use cases like customer churn prevention. Customer churn prevention. What is customer churn prevention? When the okay, so customer churn prevention means that when somebody is leaving a network or a customer is leaving the network, what what are the how we would stop him, or how would we understand the leaving or the reasons behind leaving a customer. The next second is network performance optimization. So let's say, okay, let me go back to the customer churn prevention. I'm not okay, let me describe it again. There are some questions. So when a customer is leaving the network, or leaving, or I mean terminating the relationship, you need to understand what actually happened. We need to go through entire data and try to figure out what were the reasons why a customer is leaving our network. Okay, and if we have enough data of customers leaving us, we can always predict whether a particular user is about to leave. So we can predict that one day before. Okay, yes. All right. So there's confusion about the term customer churn. Customer churn is essentially used for customers coming back, and so it sounds like customer churn prevention is we are trying to stop the customer churn, but the idea is to retain the customer. All right. So you got it right, Harrison. So idea is to retain the customer, and whatever it takes to do that, we basically can get those insights from the data. And whenever a customer is leaving us, we can always figure out what is it, what are those factors based on which the customer is leaving us. And we can also predict if a customer is about to leave. All right. The second case is the network performance optimization. What is network performance optimization? So in a network, in any telecom network, there are, based on historical data, there are very various network performance breakdowns, the performance fluctuation, or the load fluctuation, or the load suddenly going high. And it's very important to be able to predict the load in, and hence it is very important to do the network performance optimization, so that imagine that we have we figure out that most of the networks are really busy in the daytime nearer to the office, while most of the networks are free during daytime when during daytime near to the residences. So because people are moving. So based on these kind of insights from the data, we can always do the network performance optimization. All right. So we have some Q&A. All right, I'll take the Q&A after this slide. And okay, network. The third one is calling data record analysis. What does it mean by calling data record analysis? Let's say we have a lot of calling data and we would like to analyze those records. So for that kind of analysis, we require big data. With that analysis, we can generally figure out the various pattern amongst the users. The fourth one is analyzing network to predict failure. Analyzing network to predict failure. So this actually, this is one of the, well, this is one of the problem that came uh, around a week ago. Somebody actually wrote to us asking for, can we help them predict the network failure? And it's a combination of machine learning and big data problem. So what companies generally do is they monitor their towers, they monitor their infrastructure at a very large scale, and keep a note of whenever there's a failure reported. So since we have the past historical data as well as we have the information about when did a particular network fail, since we have both of these information available, we should be able to predict the network failure by analyzing the network. All right. Now, let me take some of the questions and then I'll continue with the big data customers. Okay, so all right. One of the question is from Karthik. One of the questions is from Karthik. What is the data type of blockchain blocks in the blockchain technology? Structured, semi-structured, or unstructured? Okay, it's basically unstructured from our point of view because we cannot really think of having only the tabular structure. Okay, so we cannot really we cannot really all right, so we cannot really present the data in the tabular format, and therefore we will categorize it as unstructured. Good question. All right, so now next question is why don't we split data into next question is why don't we split the data into fragments so we can perform analytics on it? Okay, yes, we do that all the time. Okay, yes, that is the strategy used in many bugs. All right, so good, very good point. A question is, for real-time systems, you need distributed systems. Generally, for real-time, do use we do use the distributed systems, and it is definitely giving it a try, as in there could be minor slowness in the beginning, but when the for the bigger data and for more faster data, we should be able to handle it using the distributed system. If you want to take a look at an example of a real-time system in which we want to do the okay, let me just take a look at this one. I like to show you. I would like to show you an example of the use case. Okay, so if you go to our blog, you'll find this example here. Okay, so we have dashboard. Yeah, you should take a look at this blog post. Okay, let me just take it out. All right, so that's one example of the real time. All right, so for real time systems, do you need distributed system? The answer is yes. A question is involving 4 computing components mentioned. Is there a basic formula that compute for file transfer speed and latency? No, there is no standard formula for that. Okay, there's no standard formula for computing the file transfer and latency. This you can do the computation based on number one, the disk read speed, and based on the strategy used by the copying program. All right. A question is Is there any specification for NIC network card for big data? No, there is no specification as such. The tendency is to have the best NIC possible, but the idea with big data is that instead of transporting data, we would be doing the processing nearer to the data. So we send code or logic to the data instead of transmitting data over the network. A question is, by the way, I'm just curious about how can I be of potential to support Spark MLlib framework with respect to recommendation in the future as a developer? All right, a good question. As a developer, basically, you will be surprised to know that it'll be the recommender systems. It'll be the engineers who handle the recommender systems, and most of the work is handled by the engineers. Okay, as a developer, you will be you. It is expected that you will be able to do the recommendation engine using Spark MLlib. All right. After the course, you shall be able to do that. We will have an example of recommender in one of the hands-on sessions. Okay, what tools will I need together with Spark knowledge and skills? You will require the uh, maybe a bit of SQL knowledge or data frame knowledge. That's all. Okay, good question. All right, a question is is performance varies with location of data store like on-premise or public cloud? Okay, so let me just make it full screen. Question does performance vary with location of data store like on-premise or public cloud or hybrid? Yes, it does. A question is, what are the examples of ETL? Converters of unstructured data into structured data, which are compatible with Spark. So some of the examples of ETL tools are, say, Microsoft's ETL tool or Informatica's ETL tool. And I think Informatica's ETL tool is now compatible with Spark. Next question is, what are the components of big data? We will talk about the components of big data in Hadoop if that you're looking for after some time. All right. Great set of questions, and let's move ahead. Any questions before we move? No questions? There are 5 more questions. Let me answer those. A question from Nikhil is Python a good start with Scala? Yes, it is good. You can start Python with any language. So you are not going to be on any disadvantage by not learning any particular language. Okay, so it's okay to learn Python as well as Scala. A question is, regarding what you mentioned, bringing the code nearer to the data, instead of transmitting the file, if we are trying to achieve real-time via a LAN as bottleneck, how do you achieve that with the help of distributed computing? Okay, so in real-time cases, we generally don't, what do you say, don't take the code. In case of real-time, since in case of real-time, the data that is coming per second is not very high. Therefore, we generally don't take the code to the data because it's not stored anywhere. It is coming real time. Therefore, the processing of near real time is a different behavior. Okay. So again, in case of real time, we don't take the code to the data, and instead we will basically keep on consuming the new incoming data and keep on distributing that computing to various machines. Okay. A question is landscape of big data as in vendors and solution offering that we are going to talk about soon. Okay. A question is could I build hands-on experience outside big project that is by myself? Of course. That's what is the purpose of CloudxLab. Question is there any good reference book for Spark apart from a specification document? There is a book called Learning Spark that was supposed to be good, but since that version has become really old and therefore it doesn't make sense to follow that book. So again, I'm coming back to the online books. Free the documentation is the one of the best. Okay. Question is, there are so many things like Scala, Hadoop, Spark, Python, which will be replaced, which will be placed where any flow and usage of big data. We're going to talk about it very soon. All right. Any prerequisites before getting into big data? I would suggest that you have a bit of knowledge about SQL. That will help you the most, as well as if you have done some experience in any programming language, that would be good enough. All right. A question from Robin is regarding the tool data framework beside SQL, which I can use, with Spark as tool. What are the examples of data frame tools? Okay. So regarding the tool data frame besides SQL, which I can use with Spark as a tool, what are the examples of data frame tools? So the biggest example of data frame tools is Spark SQL that provides the data frame in case of Spark, while the other data frame tools are like R and other languages, but those are completely different ideas. Okay. A question is what is the difference between business analytics and data analytics? In data analytics or business analytics, the terms are different, just that generally the business analytics focuses on business problem, while data analytics generally focuses on the data. So business analytics is generally vertical specific, such as HR analytics and so on. So those are a very small domains of analytics. While data analytics is more towards generic computing or generic usage of tools in order to give you the results. Okay. All right. Great. Great. Great set of questions. Oh, there are 4 more questions. Okay, those are already answered. All right. Okay. A question is regarding online books you mentioned. Can those be downloaded? Yes, those can be downloaded into PDF. You can just take a look at the documentation. They do provide the documentation in PDF. All right, wonderful set of questions. Okay, there are some more chats as well. All right, great. So we are going to cover whatever tools are required for big data as we go ahead. Next is the healthcare and life sciences. Okay, so similar to the telecom and other verticals, in healthcare, everything is kind of big data. Either it's a complex problem or it's the volume. Okay, so in healthcare, say for example, information exchange related to health requires both sides of the systems to be handled humongous data. Second is gene sequencing. Gene sequencing is really complex topic. The third is healthcare improvements. The healthcare improvements, the healthcare improvements require us to analyze humongous amount of patient information, their past behaviors, their past recovery rates, and so on, the kind of medicine they used, and so on. So that is there it requires a lot of data processing. Next is the drug safety. Now, with respect to the drug safety, again, drug safety is all about A/B analytics, right? So the term A/B testing actually comes from drug safety. So for example, let's say there is a new medicine and we would like to test the effect of it, whether it is really effective on the users or not, on the patient or not. So what we generally do is we break it into two parts, as in we keep two medicines. One medicine which is just nothing but drops of water, while the other medicine is the real medicine. So what we do is we take 50% of the patient and we treat them with the real medicine, while remaining 50%, we treat them with with nothing but some drops of water. Okay, and then observe crit, observe it for the effect of the medicine or the drug. So drug safety is exactly the one that brought in the A/B testing into the e-commerce world, and all the principles of drug safety or drug testing is used are used in e-commerce as well. So drug safety requires us to do the analysis of many test cases parallelly, as well as we need to observe the effects on large scale. So therefore, drug safety is another case where we have use case of big data. All right. So great. I would like to make a few changes here. First one is, okay, that I'll do it after this. So there are many solutions available for big data, handling big data. One is cloud-based, other is local. Cloud-based could be such as AWS or Google Compute Engine or MongoDB. All right. So let me rephrase what I'm trying to say. Big data solutions either can be installed on your premise, or you can use the off-the-shelf solutions provided by the giants such as Amazon and Google. So they have their compute engine, they have their, Google has their compute engine, AWS also has their compute engine on a larger scale, and Amazon also provides a way of storing humongous data, as well as Google also provides a way to store humongous data. So either You could go with the cloud offering. In that case, you will have to transfer all of your data to their clouds. Or we could also have the local installation. In local installation, we can go with, say, Hadoop and Spark, or we could go with Cassandra or MongoDB. But out of these four choices, like we can have a combination of Hadoop and Spark, we could have either Cassandra or MongoDB. The best choice is generally the Hadoop with Spark. Okay, best choice is generally the Hadoop with Spark. Why? Because there you can handle all kinds of data. While if you're using Cassandra or MongoDB, you can handle only this semi-structured or structured data. While in case of Hadoop, we have a lot of tools, a huge ecosystem to deal with all kinds of data. Okay, so we have two kind of choices, either cloud-based or on-premise. In cloud-based, we have Google Compute Engine, AWS, Bluemix, and Microsoft Azure. And with respect to the on-premise one, we have Hadoop and Spark, or Cassandra, or MongoDB. So Hadoop and Spark generally come together because Spark only provides computation, while the Hadoop provides storage in the form of files or in the form of tables. Okay, so Hadoop provides that storage in the form of, say, files, which is called HDFS, and it also provides a kind of structured data store, which is called HBase. Okay, so basically, out of these choices, the best choices are basically Hadoop along with Spark. All right. Now, okay, so we'll talk more about Hadoop after this. sh- Okay, as we go ahead, there are a few more chats. I'll answer those questions. Yes, thank you, Bharti Raja. Yes, Azure is from Microsoft that I have not included. I will include it in this. The looks like Cassandra is not part of Hadoop. That's right. We need to separately purchase or install. Again, Cassandra is open source, so you don't need to purchase, but you can generally install. Okay. The solution would be with both storage and computation function. That's right. So 2, 3, 4, 5 only have storage function. 2, 3 have only the storage, as in 2, 3 have only the structured storage. While in case of 4 and 5, they have all kinds of solutions for structured, unstructured storage and computation, but they are costly, as well as you have to transmit all of your data out of your premise. Okay. A question from Hitendra is, Spark is independent of Hadoop? Yes, it can be used independently. How the data is stored in AWS, could you please explain in brief? So AWS provides many services. One is called Redshift, other is called S3. So you could either upload your data to S3, or if your data is structured, you can store that in Redshift. Okay, a question from Imran. Can you let us know, is stack from which we will be used were? Could you rephrase your question, please? Can you let us know which is the stack from which we will be using were? No, I'm not able to figure out. Could you please rephrase? I know that you need to, can you just rephrase the entire question? Okay. So a question from Anup is, how about security of data in cloud environment? How about security of data in cloud environment? Yes, a very good question. So when you are pushing the data to somebody else's cloud, cloud is nothing but somebody else's computer. Okay, so when you are uploading the data to somebody else's cloud, right? So generally there are concerns about security, though Amazon or Google takes care of the security, but still you never know whether they are looking at your data or not. That's why all the competitors of AWS generally they move to their own private clouds. Say, for example, Target moved out of AWS because of exactly same question in the mind. All right. A question from Imran is, can you let us know in stack from which is used were? I'm sorry, stack from which is used were. I'm not able to figure out your question, please. Can somebody else rephrase? Is it only me? Can you let us know in stack form which is used where? Is that your question? We are going to talk about the stack very soon. Don't worry, Imran. If that is your question, we are going to talk about Hadoop and Spark examples very soon. There you will get a clear picture of what is used where. All right, wonderful set of questions. Now, a question from Binta is the solution should be with both storage and compute. I think this one I have answered, Binta. Was I able to explain? A question from Robin is that when you said on-premise and not cloud-based, do you mean that on-premise at customer or local private data center location? I would say local private data center location. Good question. So you can install anywhere. Okay. A question is, can Apache Hadoop and Spark integrate with Google Compute Engine? So they do provide ways to interact. They do provide APIs, but I'm not sure that what all URLs or what all kind of formats Hadoop is compatible with Google. Okay. Though Google is trying their best to make itself compatible with the open source. Okay, but I'm not sure if it is viable to read all kinds of formats, but it should be possible. Okay, it should be possible. Okay, a question from Binta is, what can cloud computing do with big data? What is cloud computing? So cloud computing is nothing but computing at somebody else's computer. Okay, cloud is nothing but somebody else's computer, and cloud computing is basically doing the computation on somebody else's computer, and therefore cloud computing can do many things, because if, let's say, there is the computer somebody else somewhere it's running, you can log into that computer and check what's going on there. Okay, so using cloud computing like you are using CloudxLab, so in the same way you can use any cloud. All right, good question. A question from Robin is, as big data solution, are Apache Hadoop and Spark in form of cloud solutions? What can be used instead of AWS and Google? You can use Azure, you can use IBM Bluemix. So there are quite a few solutions out there. All right. So all right. So before taking a break, I would like to ask all of you to go to cloudxlab.com. If you have not registered already, register for the lab. You can say click on free lab trial. Okay, you can click on free lab trial, or you can start for free this site. So you will get 1 week's lab for free. After you sign up with Google, you will get a, let me just try to sign in. Okay, I'm not sure if I already purchased. Okay. So I'm just trying to show you. Okay. All right. Okay, never mind. So you can sign up there. So for signing up, you might have to just provide the credit card. Credit card does not come to us. It remains with Stripe, which is our payment gateway. So uh, I'm sure your credit card details will be completely safe. They will not be saved by them. So don't worry. When you sign up for the free trial, you will have to make a payment of $1. That will be refunded in couple of hours. So this way you can start trying the lab right away. The lab provides you all access to all kinds of components in the cloud, and you can basically use all the components and follow the exercises and so on. Okay, so make sure so I would suggest that for this session, because we are going in the second half, we are going to basically do the hands-on. So it'll be a good idea if you all of you can sign up and do things together with me. Okay, so a question is, why credit card is required? Good question. Question because since we are providing the entire ecosystem of components, the chance of misuse is there. Therefore, it is important, it is mandated by the government to do the KYC about the user. That's one of the reasons why we just take $1 and then refund it back immediately. Okay. So that's the only reason. It is kind of know your user, or we call it KYC. It's kind of you know knowing a bit about the user, because this is the environment we are providing. It can be misused. Okay, we can't really, if we start stopping the misuse aggressively, it will hurt our users learning. Therefore, we are not aggressively constraining the users on CloudxLab. Okay, all right. Besides lab, theory and basics will be cleared. Yes. Okay, so feel free to sign up for the lab. That will help you in doing the hands-on today. And I would strongly suggest that you should take up the lab. It's free for 7 days, and that will give you an idea about what components do and how do they look like. Okay, so we'll continue from Hadoop after the break. So we will be back by, okay, so let's take a break of 15 minutes. All right, we will be back by 9, what would be that? 15 minutes is going to be 9:50 p.m. IST. Great. So let's start, and let me just take a look at some of the questions. One of the question is from Saurabh: is Spark MLlib better than Apache Prediction IO? I will have to take a look at Apache Prediction IO. And I can tell you that MLlib is far more popular than the prediction IO. I'll have to take a look at exactly what does it do, and then I can give you a better answer. All right. So good. Now, a question from Robin is that can you cite a simple link, for example, at Google, where I can get the recommendations data to apply Spark MLlib? As part of integrity check, is there a way that we can validate the accuracy, integrity of recommendations, information slash data provided that we will parse, etc., using Spark? Yes. In this course, we will cover one example. In this course, we will cover one example where we will generate the recommendations, and we will basically do the validation of the same and see how well our recommendations are doing. Okay, we'll do that as part of this course. If you want, you can actually, you will have the access to that if you have taken the course, right? Since you have already taken the course, you will have access to the Spark MLlib session. You can take a look at that. Okay. All right. So wonderful set of questions. All right. So wonderful set of questions. So moving ahead now. So what is Hadoop? Hadoop is an ecosystem of various components for big data. I will basically do a very quick introduction of this one because we need to focus on more on Spark today. So Hadoop is basically created by dog cutting. They were trying to build a search engine like Google, so they implemented the papers by Google, and that became Hadoop. And it was named after toy elephant, and it is under an open source license called Apache. Apache is the name of the license. Apache was Apache was basically long back there was a server, and actually today also that server is the most popular server on the internet. So Apache is a web server which is used by most of the websites, and so that basically became a very popular and still open source. So based under that umbrella, many projects came up. So that Apache, instead of being only the software, it became a license. Now it has the same license. Hadoop has the same license as Apache. It has the Apache license. Basically, it's a most liberal license. You can use Hadoop for education, commercial, or or any other kind of work. You can definitely use the the softwares which have Apache license. Okay, is popular as well as powerful and supported. It's a framework to handle big data. What it means is it's for distributed as in using multiple computers, computing using many computers, scalable, meaning in case your number of computers increase after a while, and reliable computing. So all of the components under the Hadoop ecosystem are 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 for for the cases where in case one of the computer goes down, still everything works fine. So all of the components under the Hadoop umbrella are for distributed computing, which means using many computers, you can run all the components as well as scalable, reliable, and so on. Okay, it's written in Java. Now these are the various components of Hadoop ecosystem. Do you want me to go over them or should we skip and go ahead? Yes? Should we go over them? Should we explain or should we move ahead and okay. So Bintao's suggestion is let's explain the components briefly. Okay, let's just go ahead with briefly and then we'll go ahead with Spark. All right. So so Hadoop was one such system which was designed for handling humongous data. So Hadoop's ecosystem, the most important component of Hadoop is the Hadoop file system. This file system is just like any other file system. You can create files, you can create folders, you can store, upload data into it, and so on. This file system, the interesting part about this file system is that it runs on many computers. Let me show you before, as I talk. Okay, so this file system is basically, you can go to my lab. Okay, you can go to my lab, click on Hue. Okay, you can go to my lab, click on Hue, and click on File Browser, right? So this is, for me, there are many folders, my past data. You can also upload your data and you will have similar kind of folders. So here, this data, and here, this is my home folder. You can see this is my home folder. And if you go up, this is the whole file system. It has the data about the data from, you can say, Hive, HBase, and other components. So you can see that this file system is an interesting file system because it has files, it has folders you can upload. So exactly like Unix system, it is there. But these folders are different from what are the local folders on the machine. Okay, so this is basically a file system which is running on top of many machines. Okay, which is running on top of many machines. Some files are on one machine, some files are another, part of some file is on one machine, part of some file is on another. So basically, this file system that you see is an interesting file system because even if you have a file which has couple of petabyte size, still you can store that kind of file in this file system, right? So this is HDFS. HDFS is a very interesting file system. A question from Saurabh is, what is the password for Hue? So if you go to my lab, you should be able to see login and the password. So you can copy paste. If let's say I'm coming for the first time, this is how it's going to look like. Okay, so I'll just take my login from here and and copy it and paste it. Okay, and I'll just copy my password here and then paste it here and then sign in. All right, so everybody gets their own personal workspace, and you can, after you log in, you can go to file browser. So this is the HDFS file system. You can access this file system from using the console. You can also mount this file system on your on the local computer. All right, good. There is one more question. Let me just take a look at that. All right, wonderful, wonderful. So great. So you can see that right. So that is the file store. File store means it is the Hadoop distributed file system. All right. Next is, okay. The next big component of this ecosystem is Yarn. Yarn is like an operating system. What is Yarn? Yarn basically is like an execution engine for the whole ecosystem. It runs the whatever program you give it to, give it to Yarn. It runs it on many computers based on your requirements. So various applications write their basically various applications write their Yarn application. Say, for example, MapReduce, if they want to execute, if let's say you are writing a new application and you would like to be executed on top of Yarn, you will have to create a Yarn-based application. Okay, so on top of Yarn, you can execute anything that basically is compatible with Yarn. So you will have to implement all the things that Yarn demands before you can execute on Yarn. Therefore, you generally do not, as a user, you generally do not create frameworks that run on Yarn. Instead, you use the frameworks like MapReduce or Spark. So earlier here, you can see this is the Yarn. Yarn is like resource manager. Yarn's full form is yet another resource manager. Okay, what does it do is it basically keeps track of all the resources in the network. And when you want to execute something, it will execute it based on various constraints, such as which machine is free, which machine is busy, which machine is nearer to the data, which machine is farther from the data, and so on. So it basically takes that into consideration. Now, after Yarn, we have the MapReduce compute engine on top of Yarn. So this MapReduce compute engine, the MapReduce compute engine is basically the main execution engine. So this MapReduce compute engine is one of the compute engines where we write our program for MapReduce and it does execute it. The other one, you can see Spark. Spark is a competitor of the MapReduce. It is far more faster than MapReduce. So all the components that earlier depended on MapReduce, are being replaced by their siblings uh, from Spark. Okay, like for example, the other components like Pig, Mahout, they were basically dependent on MapReduce. They're being replaced by Mahout is replaced by Spark MLlib parallelly here and so on. Okay, now Next is HBase. Here you see this. This is HBase. HBase is a very interesting product. What it provides you is what it provides you is the database kind of structure. In HDFS, in Hadoop file system, right, you can only upload file and you can create folder and so on, but you cannot keep records. If you keep records, you will have to keep it in a file and you can't modify per record basis. If you want to modify your data per record basis, you will have to use HBase. If you have millions of records, then HBase would be a better bet. Okay, so that is HBase. HBase basically lets you modify thousands of records and millions of records per second and thousands of records per second, and you can upload millions of records with millions of columns and millions of rows, and that is HBase. So HBase stores its data files, the data files like you have Microsoft data files, right? When you have you storing data into Microsoft database, it stores the data files on the local file system. Here, in case of HBase, it stores the data files onto HDFS. Now, there are few questions that I need to answer. First is from Karthik. What is the recommended infrastructure for dev and production? Okay, the recommended infrastructure for dev and production is the recommended infrastructure for dev and production. Generally, what we do is um, in we have two separate cluster. One is the real cluster, the production, and we create a separate small cluster for the devs or for the testing. Okay, but we don't have less components in the test as compared to the production. We generally have exact copy of the production in the dev. All right. Question is, what about Hive? Can we bypass in Spark? Yes. So in Spark SQL, you have the same functionality as Hive. Also, you can use existing Hive. Do we need to install each components individually? Not really. You have packages like Ambari that install all of these components. All right. So if you want to understand how to install these components, take a look at the last blog post in our blog. So if you take a look at our blog, we have just published this blog post on how to set up a lab like CloudxLab, right? So you can try this out and that should be good. Okay. Good. So on top of MapReduce, there is another component called Hive. So instead of coding, we basically write SQL query that get converted into the code that runs on many machines. So using Hive, you can process structured data happily using thousands of machines parallelly. Okay. All right. So Piglatin was one of the very important component earlier, but it has been largely replaced with Spark. Okay. Mahat was also very important component. It was basically machine learning library. It has been largely replaced by Spark MLlib, as well as Mahat is being rewritten for Spark. Okay, so that it can run on top of Spark. So for workflow, we generally use Uzi, and for importing the data from Flume, from if your data is continuous and unstructured, we use Flume tool to import the data into HDFS from external world. And if you want to copy the structured data from existing databases onto Hadoop, you can use Scoop. So these are the various components. In a typical project, you have many steps. So you generally tie all these steps together using a tool like Uzi. So like, for example, in a typical project, you will have Flume. Flume is for pulling the data from various services onto HDFS. Then let's say after pulling the data, we are using Pig for cleaning up some data. Then we are pushing the data back to HDFS. Then We are processing or doing the prediction like recommendations using Spark MLlib. Then we are saving back the results into HDFS, and then using Scoop, we are sending the data to our web server. So this is a example of a typical project. Say we want to do, what we want to do is we want to display the recommendations on our website. We want to display the recommendations on our website, and our website runs on, say, MySQL. Okay, so what all we have to do is, the recommendations are being generated based on the user's log. So we first of all use Flume to pull the user's log from the web server logs into HDFS, and using analytics engine like Pig or Spark or any other MapReduce, we clean up this data and store it in HDFS, prepare the 3-column data with user ID, product ID, and the ratings, and then feed that to Spark MLlib. And afterwards, we we push the data after MLlib, the recommendations. The result of MLlib is what? Recommendations that this user would like to buy that product. So we push that back into HDFS. From there, we put it using Scoop into MySQL, which is being used by the web server. So this whole ecosystem is put to use in such kind of projects. So you can see that there are so many components: Flume, Scoop, Pig, or Pig, or say Spark SQL, or Spark MLlib. They're being used in a single project. All right. So this is how we generally use these components. Okay. And once we have created this whole workflow, we would basically would like to run it via Uzi. Uzi would run it every day. Uzi would run it every day, and Uzi can help you define the workflow. That don't run this before we get the data. Don't run MLlib before Pig is executed. Or you can say that as soon as Pig finishes execution, Spark MLlib will kick in. And once Spark MLlib has finished giving you the recommendations, then automatically Scoop will kick in and copy the data and send it to web server. Okay. A question is, Uzi is kind of ETL. No, no, it's not ETL workflow. It's basically a workflow. I'm not sure about Informatica workflow. And so this is basically, Uzi is like Maven or Ant or Make or those kind of tools where you can define various tasks and it can execute them in a sequence manner. And then we can schedule those tasks to be executed on the cluster at later point of time. Okay. Now comes the Apache Spark. Okay. There are a question from Noor. It's evident that all components use Yarn for distributed computing except HBase. Why? How does HBase internally work? So actually HBase, HBase provide you that you can query HBase using MapReduce like infrastructure, that in with like the MapReduce you get the record, here you get the row of HBase data. So when you want to do that kind of computing, then you use basically when in case of HBase, it doesn't provide you any compute engine as such. All it provides you get and set or get and update. But it does provide you a way to process data using MapReduce. So we can use that. We can use that to process data on top of Yarn. Very good question. All right. All right. So a question is, it is like schedule tool. Yeah, maybe it is like mostly like schedule tool. Good. Now coming back to Spark. So Spark basically is a competitor to Hadoop's MapReduce. It's extremely fast and it's a general engine for large scale data processing. It's okay. So it's 100 times faster than Hadoop MapReduce in the memory. It's 10 times faster than Hadoop on the disk, and it builds on similar paradigm as MapReduce. It is very well integrated with Hadoop. So here is a classic architecture of Spark. So Spark core, So let's take a look at this. This would clear the idea about Spark. So Spark core is the main component of Spark. This is the one which takes care of distributed computing. It provides you the main constructs such as RDD, which is used by the entire ecosystem. So Spark RDD or Spark Core can run on top of Hadoop Yarn. It can run on top of Amazon EC2. It can run standalone if your company has no resource manager or your company does not have any installations of any Hadoop or any other resource manager. Okay, so in that case you could use this in standalone mode. And there is something called Mesos, which is basically a competitor to Apache yarn, Hadoop's yarn. So basically Spark can run anywhere. Spark can run anywhere. So you wrote a program for Spark. It can run on your desktop. It can run on Hadoop. It can run on Amazon, Amazon version of Spark, and it can run on top of Mesos and so on. So so you can happily write your code for Spark, which can actually run everywhere. So the Spark core can write as well as read the data from all kinds of sources. It can read the data from HDFS, it can read from HBase, it can read from Hive, it can read from Tachyon, which is called Elixir now, and it can read from Cassandra and write back to them. Okay. On top of Spark Core, we have many convenient functionalities, or you could call them libraries, or you call them packages. So these libraries, packages, or functionalities or bundle of code is basically using Spark Core. So you have data frames where you don't need to really write the code. While in case of Spark Core, if you are writing directly for Spark Core, you will be writing the various conditions, if else, loops, and so on. But in case of data frames, you can simply write the query language like SQL and happily process the complex data. You can process the structured data using data frames. So data frames are one of the things that are really, really powerful and really useful to process structured data. Then we have, in case your data is coming fast and you need to process continuously in real time, then you need to use Spark streaming. Spark streaming makes it possible to run parallelly, run continuously on the network. Okay, so that's Spark streaming. Let's say you want to process data which is coming continuously online from your server, and you want to show the trend that's going on in real time. In that case, you should use Spark streaming. The link, the browser link, the blog link that I shared with you, that one demonstrate the use of Spark streaming to a very large extent. Then we have MLlib. So MLlib is machine learning library of Spark. It's nothing but complex functions written for machine learning off the shelf. So you don't have to write those functions, and they utilize the Spark core, and basically Spark MLlib get the work done of machine learning complex computing using many computers. The next one is the GraphX. What is GraphX? GraphX is for graph processing. GraphX is for graph processing. Let's say you have a complex structure of data. This person is following that person is following somebody else, and so on. You have like full list of people who is following each other. And what you would like to do is you would like to figure out who is the most important person, who is the least connected person, who is the most connected person, so on. That is graph processing. Graph processing is done with GraphX. Okay. Now, there are many languages are supported by Spark. So it's not only that you will have to code in Java, or you will have to code in Scala, but You can code in SQL, you can code in R, you can code in Python, you can code in Java and Scala. So there are many languages that that Spark supports. This course is going to cover Spark with Scala, but you are free to use Python parallelly if you like that. Okay, I'll give you I'll show you around that. How does it look? So, okay. Now, before we jump ahead, I would like to show you the other tools that okay that we have done so far. Okay, so we did not do the hands-on. Okay, now let me just show you the previous component that we talked about. So here we talked about Hue. So using data browser, you can go to HBase, interact with HBase. Using this, you can interact with Hive, and using Pig, you can interact with Pig. And using Job Designer, you can interact with Uzi. Okay, you can draw the graph of jobs and interact with that. Okay, so you could, okay, not job design, all right. You could say workflows, dashboards here. You could click on dashboards here. Okay, so here it shows that these were my jobs. These are suspended jobs. These are, okay, did not work out. Okay, so now let me just go to say here, workflows, editors, and workflows. Okay, so here you see that we can create our own workflow by clicking on create. This is Uzi workflow, so you can drag and drop various things. You want to first run Pig, you want to run Spark, you want to run Java program, you can just drag and drop these and create a workflow. Okay, I'm just typing something to complete the workflow. So this is Uzi, the one that we talked earlier. Okay, and so on. So using this, you can actually create the entire workflow by dragging and dropping. Okay, so this is Uzi. Now coming back to the Spark. Now, so this is not required. All right. So the next thing that we need to do is take a look at, say, the Spark. So the way you can look at the Spark is by logging into console. How do you log in into console? You can take the login, paste the login node, and then take the password, paste the password. You can see that when I type the password, it doesn't show asterisk or anything. It is just completely blind. And so sometimes you might think that nothing is being typed. So this is the console from which we can launch, say, PySpark. PySpark is Python version of Spark. Okay. You can also launch other versions of Spark. Okay. You can take a look at these. You can take a look at these instructions here. Okay, so using this, you can launch the newer versions of Spark. Okay, so this is the way you can do. You can just copy these two into the console, and then you can user Spark. You can see Spark 2.2.1. Okay, you can run that bin PySpark. Okay, so this is Python version of Spark. In the same way, you could run Scala version of Spark by using Spark Shell. Okay, now let's say I want to launch Spark Shell. I could launch Spark Shell like this. Okay, so these are the two blocks I talked about. You could take a look at them, how to launch various versions of Spark. Okay, and this one is how you can build a dashboard using Spark streaming. So this is the Scala version of Spark. Okay, so here we go. This is just a very simple example. Okay, now Similarly, you could also launch Spark. Let's say I'll just go back here to the 2.2 version, Spark R. Okay, so you can launch Spark R just like this. Okay, it'll work eventually. So here you can see this is basically R console. So you can interact with Spark by the way of all these commands. A question from Roshni is how to log into Spark Scala. You can just execute these couple of commands I showed you here, either using directly saying Spark shell, using either the Spark shell that will execute the older version. If you want a newer version, you can execute things like, okay, like for example, this one. All right, like this. Great. So that was a quick hands-on, though it's not a big example right now, but this gives you a good amount of, how to get started. So you can just start with PySpark here and start working with the data. Okay, let me just show you. For example, I just launched the PySpark. We could also launch Spark Scala. Okay, or let me just show you with Scala. And let me do the word count, and you'll get the idea that it's actually pretty simple. Okay, so I'm launching this Spark shell. How to get out of the shell? You can just press Control D and you will be out of it. Okay, so I'm at the prompt where it shows Scala here. I'll say sc.txt file, that's a entry point, entry point. So here, just don't worry. I am just going with very simple one. I'm going to data, load data first of all from this text file in slash data slash input and slash word count slash data mr word count and input. Okay, this way I'm trying to load data from HDFS. Okay, don't worry if you don't get it. I'm just showing you that yes, it does work. So here it is showing us the one line from the file. Okay, this is the line that is showing because we asked only for one line. Okay, so next thing, let me see if I could do really quickly. So I'll say data dot, okay, so we have data and then we'll say data dot flat map and we'll say, okay, x dot split. We are splitting data based on the word count, based on the space, and then, okay, it has to be this way. Okay, next. All right, then we can do map and we'll say x to a tuple, or you could just return, okay, so flat map is not a member. Probably we are making a typing mistake here. All right, so this way we could do reduce by count, and I'm doing the word count. All right. Not reduce by key count, it is reduced by key. All right, so you can see that we can basically say take 20 Okay, so in a single line, we have done the word count. Okay, you can see that it has done the counting of the words. It's a very, very simple counting the words. Okay, if you want to give it a try, give it a try. Okay, I'll just give you this first command first, and then second command. Okay, so why I want to do this, the purpose is not that you will be able to understand it right away. Okay, so these are the two commands. So again, let me just copy paste again. I'm just separating it properly. So these are the two lines using which we have done the word count from the text file. The same thing could have taken us uh, a lot of hard work in MapReduce. So okay. So first command is sc.text file. It's loading the data. Second command is breaking the data into key value pairs and doing the word count. Okay, so using Scala as well as using Spark, you can see that even terabytes of data can be processed with very, very simple code. All right. So the first line which says sc.text file, it's basically that input data command. Great. So this was a quick hands-on you must try in your free time. And if you have taken the account, you can directly create this, create your own MapReduce, first MapReduce very quickly. And I did not have to keep some code snippets ready. I was able to type it. So that's the magic of MapReduce, magic of Spark. And in this, we did not have to basically type too much code or compile anything or do anything. We were able to quickly check whether we were able to load the data or not, and this. Although you can definitely create applications out of it, and it's pretty simple and it's really quick. This is another reason why Spark is very popular, because it lets you write the code really fast, and you don't have to work too hard on that. So the whole MapReduce is done using these two lines. We are reading from HDFS. Okay. We can also save the results. We can also save the results into the HDFS saying save as text, save as text file. And let's say I'm giving it some folder, or let me just put today's date. What is date today? Today is say 18 March 2018, and this is the folder I'm giving, so it is going to put this into that folder. Okay, so you can see that it's pretty simple to actually run the code with Spark Shell. All right, Binta was able to answer your question regarding the input data command. The first line is the one which is loading the data from HDFS. Okay. What does it say? It says there is no program call, no file, no this. Let me just show you. It's called save as text file. Okay, so no worries. We'll just change the cases. All right, what happened here? Because we are using it after take. That's the reason. So we'll just execute it like this. All right, so it has saved the result into HDFS. So it's basically we are using Scala. We are going to deep dive into Scala. Don't worry about this code. The purpose is not to scare you with the piece of code. The purpose is to show you that it is so simple to write the word count program. Okay? It is so simple to write a word count program. Now it has saved the results in this folder. We can take a look at that by going into HDFS. You could go here in the hue. All right. So in my folder, if I sort the data by the date, I'll see this folder. This has three parts, and these three parts contain the results. Okay, so you can see that this is the word count. All right, so this is what the word count looks like in Spark. All right, so we will go into more details about Scala in this course, and then we'll do a lot of processing and a lot of projects on Spark as we go ahead. The whole course is going to be very hands-on in the sense that all of you will have to log in with me into the into the console or into the Jupyter notebook and then do the hands-on along with me. That is the sole objective of this course. Okay, that you all do the hands-on with me. Okay, there is no separate time for doing the hands-on. All of us do the hands-on together in the class. Okay, so the theory and the practice both should happen together. A question from Saurabh, can we see the order of execution in Hue now on small data? Um, Order of execution in Hue, this did not execute via Hue. This basically ran through the console, so you can see the order of execution in the Hue. Okay, all right. So that was okay. That was completely one way from my side. I have not answered many questions. Question from Vintao is, could you post the code? Otherwise, I cannot follow to type them. Okay, I hope I shared the code. Okay, could you provide the URL or the blog for launching Scala? Okay, you can actually do simply Spark shell, Spark-shell in the console, and that should be good. Okay, as well as I'll share just now, I'll just share again. Here, if you, as soon as you log in, you see the link here. It says access the Apache Spark 2 by giving the instructions. So either you can just um, use the Spark shell, which runs basically 1.5 version. If you want to, then you can follow these instructions. Okay. A question from Noor is, so once we installed Spark, all different flavors of Spark is installed. Which version of Spark is covered in this course? We are going to cover the latest version. So some part of it is same for all. So in those cases, we are going to just use the default Spark. Some part of the Spark are different. In those cases, we are going with the latest version, Spark 2 in this course. All right, very good set of questions. So I have missed some of your questions. Please feel free to ask again using the Q&A window. A question from Hitendra, did you say Spark data can be accessed via SQL? Yes, and with the ODBC, JDBC, yes. Question from Saurabh is, Spark MLlib is better than Apache Prediction IO? Could you leave that question with discussion board? I would love to answer it. Come over to the discussion board. Okay, so we'll do a bit of study of prediction IO and then we'll post the answers. Okay, so or maybe some other person can do that. All right, so you can just post your question there and we would love to answer. All right, now there are a few questions I have skipped. Let me go up. Question from Robin is, although the theory and practice should be done together, is there a way that we can prepare in advance before the class? Yes, you can prepare definitely. So I'll just show you that. So here, if you take a look at CloudxLab, along with the live class, what you get is if you go down. So along with the live class, you get the whole uh, studio recorded videos. Okay, these are very small pieces of videos which are followed by exercises. So you must prepare for the class. You can prepare for the class by going through these videos and the text. Okay, these are very quick videos along with exercises. Okay, so while the class goes on, you should follow the self-paced along with the class. All right, very good question. Now, all right, we're going to study Scala from next session. Okay. Yes, Karthik, you have a question? You have raised the hand. All right. Now, next question was, there was one question related to the flavors of Hadoop. So basically there were, let me just draw it here. So, okay. So there was something called Apache Hadoop. This was basically the main project. Then came Cloudera. So Cloudera was basically a company which started providing support because they were the first authors of the Hadoop. So they've added more bells and whistles to it, like plus Cloudera Manager, plus Hue. So that was added by Cloudera Hadoop. Okay, they call it CDH. Okay, we call it CDH, right? So they were the basically the creator, one of the creators of the Hadoop one. Okay, they were the creators of the Hadoop one. Now, after a while, the second version of the Hadoop, which includes Yarn, was written by Hortonworks. Okay, so even though this is an open source solution, the services, I would like to put it here, the service and support. If let's say you want to deploy um, in your company, then you may want a professional support. In those cases, you can use Cloudera support or Hortonworks. Okay, either one is completely fine. Okay, so they provide here they provide few tools like few tools like Ambari along with service support. So basically, plus there are few more support. So for professional versions, you could go for either of the support. Again, both these are open source and free. Okay, you can use both of them for free. All right, so that's how it is with respect to the various flavors of Hadoop. All right. Okay, a question from Raju is, do we have an option to watch them offline? You can use maybe some tool to download videos and watch them offline. Okay, if you want to, but we don't have any tools to help you with respect to downloading the videos. Okay. A question from Noor is Spark written in Java? How do you access Spark by SQL? You mentioned that Spark can be installed on your desktop, so you can run the Spark's SQL server. They call it Thrift server, and then you can access that via JDBC, as in from Java. Okay. And basically, when you say Java, it means that you can execute SQL commands and they will connect via Java and execute that SQL command. That's a standard JDBC. The way you connect your Java program to any database, in the same way, you can also connect to the Spark's SQL server. Also, there are many clients of SQL. They can connect to the Spark Thrift server, and that should be done. Okay. You mentioned that Spark can be installed on your desktop. Yes, you can download it and use that. Okay, you can just go to their website, download it, and run the bin. Okay, and please also clarify what would be the reason for installing Spark on desktop if Spark is meant to work in the distributed file system. Exactly. So just for the testing or demo purposes, you may want to download and install, but for the real work, you may want to do it on the cluster. What is the ID that is used for writing Spark programs? So if you are creating really big project, you could create that using the Scala ID if you are using the Scala programs. Otherwise, it depends on which programming language are you using. Okay, so if you want to take a look at the process of dealing with process of dealing with the writing larger programs, you should take a look at this one. Okay, you should take a look at this one. It has 16 pages, so that should guide you on how to install, how to uh, set up your dev environment on your desktop. Okay, so all right, very good question. Question from Saurabh is, what is contained in Ambari? Ambari essentially contains the whole modules for various installation and provisioning. It provides you the tools to provision, add, or remove the nodes from the cluster. So Ambari is like a tool with which you can install the entire cluster without having to go through too much of a headache. Okay. All right. So Raju's question is, can you provide download button to watch them? Actually, this YouTube doesn't provide the download button, and there is no way to for us to provide a download button. But you can use those tools like Keepwid and others if you want to download the videos. But be careful before sharing with people. If you really feel that it is okay to share the video with somebody, then just let us know. Okay, just let us know upfront. So you can use tools like Keepwid or some other tool that can help you download the videos from YouTube. Okay, there's no YouTube does not have a way for letting us provide the URL. A question from Noor: are we completing any project in this course? Yes, we are going to complete 2 projects in this course. Yeah. Okay. A question from Robin, just to clarify, does Cloudera and Hortonworks provide cloud instance for production, or are they just temporary storage for data analytics purpose? So Cloudera or Hortonworks provide software. You will have to host it at AWS or other places. Okay, they don't provide a hosting, they provide the software and the support. All right. A question from Roshni is, after completion of course, can I take up the interview and crack it? Yes, you should be able to. Okay. All right. If you finish all the exercises, there are quite a few exercises that you need to finish as part of this course. Question from Hitendra is Jupyter part of Hadoop or was just configured by CloudxLab to appear by side? So Jupyter is basically independent component. We made it such that it should appear for some of the exercises by the side instead of you launching in another window. Wonderful set of questions. Okay, did I miss anybody's question? So feel free to, if you want, there are around 1 or 2 seats available in the Spark course. So I think not this one. Okay, the view details. So here you can, right, you can enroll if you wish. All right. So there are 1 or 2 seats available for the session in this course. Okay. A question is, where can I find the installer for Jupyter? A better way to, if you want to install Jupyter, you can use Anaconda. Okay, you can use Anaconda, and with that you can install. Okay, so you can use Anaconda to install if you want. Okay, all right. So why is that? Good. What? All right. S- I've just muted everything and still it is. All right. So, so basically, that's how you can get the installation. All right. A question from Raju is how much guidance assistant be giving to use Python for all the tasks in the course? I'll try my best to give you the guidance for the Python course because we have run the course in Python earlier. So the first version of the course was designed with Python, so everything would be okay. All right. So yeah, another question from David is, hi, have a second to talk about Tableau? Sure, sure. Basically, I think the best way to experience the Tableau is, um, okay, so you can't connect. All right. Are you on this exercise in the CloudxLab? If you go to my courses, all right, and if you go to my courses, all right. So here, if you go to my courses and click on say Hive project, okay, there on one of the pages here, the visualization part. Are you following this guide? Okay. All right. So I would say that drop me an email at reach us at CloudxLab. We will take a look at it. Okay. Generally, that problem with generally there is a generally we miss that one part whereby we have to select the authentication version as Hive Server 2. Okay, that's where the mistake is. Please send the screenshot. I would love to take a look at it. All right. Great, great. All right, great set of questions. A question from Joe on follow-up with it'll be c.cloudxlab. That is our Hive server, so you give that a shot. Okay. Now, question from Joe is yes, even if you are on EFG Edge, the Hive server is running on I think C, that you can give it a shot. Okay. There are some more questions I would love to answer. A question from Joe is the follow-up on Roshni's questions regarding the interview. Will the course also cover algorithms related questions that could potentially be used in big data and ML processing? Yes. So wherever it's required, we cover the algorithms, okay, that are required and used in big data. Say, for example, we talk briefly about what is Paxos algorithms and so on. Okay. A question from Noor. I don't see Spark version for Windows here. Is there any other place? Let me see. Have they removed the Spark version? They did have the Spark version earlier. Okay. I think there would be, if you just download it, okay. If you just download it, there will be a binary that could be there for Windows. Okay. I've not used yet on Windows for a very long time. That's why. Okay, a question from Robin. In a high level, can you help us visualize the process flow on how Cloudera or Hortonworks will help in big data, Hadoop, and Spark support and service for us who has Amazon Cloud host instance as an example? Okay, so basically any issue related with the software, you should generally talk to the software support people, either Cloudera or Hortonworks, whichever support you're taking up. While anything related with the hosting, you would have to talk to the hosting provider, either AWS or others. So, so that's how it is. And I'm actually not too much an expert on their service support model with Cloudera and Hortonworks. Okay, so yeah. Question from Saurabh is, yes, we can unzip tar to use Windows. Yes, thank you. All right, great, great. So those were wonderful set of questions. I hope I have not missed your questions. And so the recording of the session is will be sent to all of you, and along with the presentation of the session in the form of PDF, we'll be sending it to you. Okay, so have a great day. And if you have more questions, please feel free to ask. We still have 7 more minutes left in the session. All right. Will the Q&A chat be shared? I don't know because I have not seen this Q&A being recorded. And how can we download these Q&As? A question from Robin is, can CloudxLab perform the support and service that Cloudera and Hortonworks can provide? We can, but that's not the model we are focusing on right now. Only in the exceptional cases, what we can do is, if one of our student is working somewhere and he wants to set up the cluster, we can help him and guide them or mentor him to do the service and the support. Okay, but for us, because of our limited bandwidth, doing the service and support is a bit harder for us. Okay. A question from Rajur is, how long this course continues? There are going to be 12 total sessions, including today's. So there are going to be 11 more sessions every Saturday, Sunday at the same time. For how long will we have access to the CloudxLab environment after the course finishes? You get a total of 3 months, 3 months of environment. If the course is going beyond 3 months, then you get extra access. But I'm not sure if what is the duration. I'll have to take a look at the uh, offering here. I don't know how many months you get free with Spark. Okay. Somebody from my team can answer that part. Okay, I think it's 2 months that you'll get the access to the lab. All right, when will we receive the recording of the session? Maybe by tomorrow evening. All right. So, wonderful set of questions. I totally enjoyed it. And there are a few more questions that I need to answer. A question from Robin. By the way, when you mentioned cluster, where are the use case scenario of setting them up? Where are the use case scenario of setting them up? Mm, you can take a look. I did not get the question. So when you mentioned cluster, where are the use case scenarios to setting them up? All right. So yeah. Okay. Could you rephrase your questions? I would love to answer it. I mean, into what component of the ecosystem, um, production-wise? So yeah. So cluster, the entire thing would run on the same cluster. Okay. All of these components will be running just like CloudxLab on the same component. All right. So great, great. And let me just answer one more question. Okay, there was a question related to the big data with the Spark course. You can scroll down, you can see that there is one course starting on 18th March. You may want to take it up. There may be around 2 more seats left. So yeah. All right. I don't see course schedule starting in March to enroll. There is 18th March. You can see that. I'll just paste the URL again here. All right. Great. A question from Joe is Big Data course a prerequisite for ML specialization course? Not really. Those are two independent courses. But for solving a large-scale problem in the industry, you may require the knowledge of both. Okay? So if you are aiming for a data scientist, senior data scientist, or data architect or machine learning scientist position, then you may want to go for both. All right. So great. So great set of questions. I look forward to see you. I look forward to see you in the next session. Okay. So all right. All right. Thank you, Noor, for finding that out. I will just take a look at these Q&As if it is giving us, and it will be good. Hiten's question is, I'm not seeing Spark in my courses. We will, I'll make sure that that happens. We are reviewing all the accounts, so we will add Spark to your courses. All right. Thank you, Noor. Thank you again for finding that for us. All right. Question from Binta is, would you like to take a look at my Spark project problem now? Um, okay. So I would love to, can I do it on one-on-one, Binta? Could you just schedule a one-on-one with me? I would love to answer that. Okay. So please do that. And anyway, so I was been planning to do a one-on-one with you for some time. So I would love to do that. So do you have the URL for doing the one-on-one, or should I send you? Okay, just schedule a one-on-one with me. Okay. All right, great. I would love to do that. All right, so great. I'm going to so great set of questions. I thoroughly enjoyed your questions. There is one more question, which is okay, which is just thanks. Okay. All right. So wonderful. So thank you, everyone. Okay. Okay. So the first session, this session is generally public and free for all, while the rest one is paid. Okay, first session is very generic and the overview of the ecosystem. So it is free for all. It is to help everybody who is from every kind of background trying to understand big data, trying to understand these components, whether product manager, program manager. So this session, the first session is very generic, so it is free for all. From second session onwards, we have only the paid seats available, because we want to keep the class small and we want to have a better experience learning together. So that's why we have few seats only. And okay. I'm really happy, Anil, that you learned many new things today. Good. Thank you, Lakshmisha, that you find it very useful. Thank you, Roshni. Thank you for kind words. All right. So, all right. Thank you, Robin. I'm very happy. All right. Great. Thank you, Hitendra. All right. I look forward to see you next week. Thank you, Riyajur. I'm happy that you liked the session. Thank you, Siva. Thank you, everyone. I look forward to see you in the next session. Bye-bye. Have a great day. Thank you, Parag. Wonderful to have all of you in the session. Please stay connected. Come over to the discussion forum. If you have more questions, come over to the discussion forum. The discussion forum is very active, and I'm really happy to have great community. People are responding to many questions, and I can see that. And so feel free to answer the questions, ask the questions on the discussion forum. Yes, Bintao, we will cover Flume, Scoop, and Oozy in the next Saturday session. So, okay, great. Wonderful to have all of you in the session. Bye-bye. Have a good day.